Hi guys, my name is Akash BR and I'm a student of Sri Venkateswara College of Engineering, Bangalore. My USN ID is 1VE23IS003 and I'm pursuing my engineering in Sri Venkateswara College of Engineering and my section is ITIL. I'm from the Department of Information Science. Uh, let's learn about chemistry today. The topic is corrosion and its types. Yeah, I know who and all know about the corrosion and the effects of corrosion. If you don't know, guys, I'll teach you. Corrosion is the gradual degradation of a material, usually a material due to chemical reaction with its environment. It can result in a structural damage or reduced functionality and aesthetic deterioration of the material. Corrosion is a natural process that can be influenced by factors such as moisture, temperature, and the presence of certain chemicals. The causes of corrosion, most metals exist in nature is combined forms, that is in the form of ore. The ore is the purest form. So extraction of the material from its ore is an unnatural process in which component of a stable system is being separated. Ore extraction. Let's go with the flow chart of the ore, how we get the pure metal. Ore extraction metal, and then the metal goes into corrosion into the corrosion product, and we get some stable gain, a metastable loss of electron stable. During the process of extraction, a number of steps like concentration, roasting, and smelting are involved, and finally, the ore is reduced into metal. Therefore, metals in their finally refined state are highly unstable and have a tendency to revert back in their original state, that is, to stable state by the process of corrosion. The types of corrosion, general corrosion, which occurs uniformly across the surface of a material leading to a gradual thinning of the material. Pitting corrosion results in localized damage in the form of small pits or craters on the material's surface. Crevice corrosion happens in confined spaces like gaps or joints, leading to accelerated corrosion due to limited access to oxygen. Uniform corrosion. There are 12 types of corrosion with pictures. Uniform corrosion, atmospheric corrosion, corrosion fatigue, intergranular corrosion, pitting corrosion, stress corrosion, waterline corrosion. Types of corrosion. A galvanic corrosion, which happens when two different metals are in contact in the presence of an electrolyte, causing one metal to corrode more quickly. Stress corrosion cracking, which occurs due to the combined influence of tensile stress and a corrosive environment, leading to cracking of the material. Intergranular corrosion, which occurs along the grain boundaries of a material, often due to the presence of certain impurities. Types of corrosion. Erosion corrosion results from the combined effect of a corrosion and the mechanical wear on a material surface. Microbiologically, which influenced corrosion. The MIC, which is abbreviated as microbiologically influenced corrosion, which is caused by the presence and activity of microorganisms and the material surface. The high temperature corrosion occurs at elevated temperatures, often in industrial settings, which can lead to rapid degradation of the materials. The factors which are affecting corrosion, environmental conditions, the moisture, temperature, and the presence of corrosive chemicals can accelerate the corrosion, which are the triggering points for the corrosion. The composition of the material, where the different metals and alloys have varying resistance to corrosion based on their chemical makeup. The surface finish. Rough surfaces can promote corrosion by providing more sites for chemical reactions to occur. The factors influencing corrosion, the nature and the extent of a corrosion which depend on the metal and the environment. The important factors which may influence the corrosion process are nature of the metal, environment, concentration of electrolyte, temperature, electrode potential, and hydrogen over voltage. Prevention of corrosion. Use of protective coatings. Applying coatings like paint, plating, or anodizing can create a barrier between the material and its environment. Cathodic protection. Utilizing sacrificial anodes or impressed current systems to protect metal structures from corrosion. The proper material selection, choosing materials with high corrosion resistance for specific applications can reduce the risk of corrosion. Prevention of corrosion, control of environmental factors, managing temperature, humidity, and exposure to corrosive substances can help prevent corrosion. Regular maintenance, inspecting and repairing any damage to protective coatings or surfaces can prolong the lifespan of materials. Design considerations, designing structures with proper ये क्या बोल होता yeah bro ಅದೆಲ್ಲ ರೆಕಾರ್ಡ್ ಆಗಿದೆ don't tell like that. ಹೋಗೆಲ್ಲ ಗೊತ್ತಿತ್ತು ಈ ಏಕೆ ಏನಾಯ್ತು ಏನಾಯ್ತು ಸರಿ ಆಯ್ತು ಸುಮ್ಮನೆ ಮಾತು ಬಿಡು. Yeah, sorry for the disturbance, guys. Regular maintenance, inspecting and repairing any damage to protective coating or surfaces can prolong the lifespan of materials. Design considerations, designing structures with proper drainage, ventilation, and isolation of dissimilar metals can help prevent corrosion. The case studies. The corrosion of the Golden Gate Bridge. I know, have you guys all heard about this Golden Gate Bridge, which usually gives constant exposure to salty ocean air has led to corrosion of the bridge's steel components, which requiring regular maintenance. The corrosion in refineries, high temperatures, and corrosive chemicals in oil refineries can accelerate corrosion of equipment and pipelines, necessitating frequent inspections. Corrosion in underground pipelines. Soil conditions and exposure to moisture can lead to corrosion of underground pipelines, causing leakage and environmental damage. The impacts of corrosion, economic costs, safety risks, environmental consequences. Let's learn about the economic costs. Corrosion can result in significant repair and replacement costs for industries and infrastructure. Safety risks. Corrosion-induced structural failures can pose safety hazards to individual and the environment. Environmental consequences. Leaking to chemicals due to corrosion can lead to pollution of soil, water, and air impacting ecosystems. Conclusion. Corrosion is a natural process that can cause significant damage to materials and structures over time. Understanding the types of corrosion factors influencing it and preventive methods is crucial for mitigating its impact. By implementing proper maintenance practices, material selection, and corrosion prevention strategies, the detrimental effects of corrosion can be minimized. References Fontana, Myers D. and the Green, Norbert D. Corrosion Engineering, M.C. Grau, Hill 2005, Joes Jenny A. Principles and Prevention of Corrosion, Pearson 1996, Davis Joseph R. Corrosion of Aluminium, and Aluminium Alloys, ASM International 1999. Thank you, guys.